Hello. Hi, everyone. Hello. All right, there's someone there. I'm Aina, one of the embryologists of Repro Clinic, and I'm here today to talk about the thawing procedure, the embryo thawing, like what it is, how it affects, what can we do about it, or what like points it has or not, and everything about it. All right, I have some questions that you have sent guys to us to Repro Clinic. And I'm one of the embryologists, as I said, so I'm just going to start answering all of them. If you guys have any questions, you can ask me here. I think you can just send a message and I can read it, or if not, you can always contact us via email. Our email is labreproclinic@reproclinic.com, and I'm sure we can write it down, so if anyone has any doubts or questions about it, they can just send us an email, or if not, just try this chat. I think I can make it and speaking and read it while I do it. All right, so I will start for the very first questions. All right, what is embryo thawing? Okay, the other day in another live we were chatting about embryo vitrification. So if you have any question about that, you can go and check that video. All right, the embryo thawing is the procedure where we actually thaw embryos. All right, there's one question over here. All right, I'll take a note and then after that I will answer that question. All right, is the procedure where we thaw embryos that have been vitrified. All right, that procedure, embryos are vitrified actually here. I showed this in the other video. All right, this is a cryotop. There's other devices, but that's what we use. Okay, I don't know if you can see, it's an open device. Here is where the embryo actually would be. Don't know if you can actually see, there's a mark at the end, like a black mark. Actually, really next to it, it's where we put the embryo there, and there's this black mark here. If you can see in the other like borders, there's no black mark. So this allow us to know in which position there's the embryo. All right, and this is like hard, but this one it's not, as you can see, and the embryos are kept here for as many time as we want in the liquid nitrogen. All right, and when we thaw, we remove this inside the liquid nitrogen, okay, because you cannot remove this out, like put this outside the liquid nitrogen. So this part needs to be inside. All right, and then we move this, and really fast we put it in a thawing media. In the liquid nitrogen, it's the temperature, it's minus 194 degrees more or less, and then it goes to the thawing media, that's 37 degrees. That's what the thawing is actually, and I keep this with the next question, that it's how many steps the embryo thawing has and what's like how it can be seen in the lab. We have the thawing step, then the diluent media, and then the washing media. All right, first of all, you need to put from here to the thawing media, and then there is where the embryo needs to, the embryo is stick here, and then when you put it, the cryotop there, the embryo start floating, and then it doesn't get stuck here anymore when it gets through that media at 37 degrees. It's really, really important that 37 degrees, and the change of temperature needs to be as fast as you can. That's why what we use is two medias. One media is the media that we're actually going to use, and then another one just to check the temperature just before the thawing. After that, we have the diluent media. It's where we will actually start cleaning this embryo that's thaw, then it goes there and the osmosis starts there, all right? And then after that there's the washing, and all the cryoprotector needs to be removed and needs to be washed from that, all right? This procedure is quite fast. In the thawing media we have the embryo just for 1 minute there. In the diluent it's 3 minutes, and then the washing it will be 5 minutes and another 1 minute. So at the end it will be around 15 minutes more or less, no more than that. I would say the most delicate procedure during the thawing, it will be the TS part, the thawing media. That thawing media needs to be it's really important, the temperature, and it's where the embryo needs to, I don't know the word in English, but kind of being stopped, getting detached from here, and it's where the like the exchange of media will start, and that's really important, because when we freeze, what we do with the embryo is, with all the cryoprotector, we remove actually the water that's inside the embryo, and we put cryoprotector, and then in the thawing we need to remove this cryoprotector and then put water back there again. Water will actually kill the embryo if the embryo is frozen with water inside, because it's like when there's snow, like the crystals would be made, and then it will destroy the cells, but cryoprotector will protect the cells at that temperature. But then if cryoprotector is still in, when we remove it from the liquid nitrogen, then cryoprotector will damage the embryo. So that's the most important part, and then and that's where all the osmolarity it's getting there. So that's quite important and quite delicate. All right. And sorry, that's pretty much. And then it needs to be like another actually kind of moment that it's quite important. It's if the embryo is actually stacked or not in the cryotop. All right. Normally it won't be if you let the right amount of media when you freeze, but sometimes it might get sticky there. So that's another moment that it could be quite tricky. Okay, when we see this procedure in the lab, what happens is that you actually can see that the embryo, that it's quite round. You see how it gets like a balloon. If you have a balloon and then there's air there, and then the air goes out, and then it gets like fluffy and like. So that's what would happen when all the cryoprotector goes out, and then you can see that, and then you can see again that that embryo will reinflate again, and it will form like a circle again. That's what you actually see in all the steps. So in the first one, you will see the embryo getting kind of dehydrated because all the cryoprotector is going out, and then you will see how the embryo gets rehydrated when all the media and the water goes in again. And I have been reading here some questions about day 5 and day 6, and the importance of vitrifying or not on day 5 or day 6, and if there's any difference. Obviously you would rather freeze at day 5 than day 6, but it's not about the freezing process that will affect if it's day 5 or day 6. It's just that we would always prefer an embryo at day 5 than at day 6, because the embryo should achieve blastocyst stage at day 5. They have still time until day 6, but if an embryo has achieved that stage at day 5, it would always be better quality than one that has achieved it at day 6. In terms of survival rate of vitrification and thawing, there's no difference. It's more about the difference of what quality that embryo will have. We would always prefer an embryo that has achieved blastocyst stage at day 5, even if it's, for example, a 4BB, than maybe a 5AA on a day 6, because that embryo at day 6 has had 1 day more. Maybe if you hadn't vitrified that embryo at day 5, maybe it's a 5AA also at day 6, and the fact that that embryo achieved blastocyst stage before at day 5, that will make a better embryo, so the quality will be much better. But in terms of vitrification, we actually vitrified day 5 and day 6. That's completely fine. And in terms of thawing and survival rates, that's the same. It's just about the quality of the embryo more than the proper fact of thawing or vitrifying at day 6, I would say. But obviously embryos that achieve blastocyst stage at day 6, they have a chance, obviously. If not, it wouldn't, like, we would not vitrify that, or anyone would. But obviously, if you have to choose and you have 2 embryos frozen and you have a day 5 and a day 6 and you need to thaw one, the day 5 will always be considered best quality than the day 6. That's what we do here at Repro Clinic. So that's our policy, and obviously it's based on studies. It's not just our policy, but an embryo at day 5 will always have better quality than an embryo at day 6. That's for sure. All right. Then another question here that we have is, how long does the embryo thawing process take? That's where I told you it's about 1 minute in the first step, then 3 minutes, then 5 and another 1. So that would be 5 plus 3, it's 8. It's 10 minutes, around 10 minutes. But obviously you need to prepare everything, so it will take a bit more. But the proper thawing process, it's around 10 minutes. All right. Then, how much time can elapse between embryo devitrification and embryo thawing and the transfer to the mother's womb? We normally leave 2 hours. I know in some other centers they just thaw embryos in the morning, and then they do the cryo transfer after. It doesn't matter how many hours. And based on some studies, we think that 2 hours it's the time that needs to be between the thawing and the transfer. In those 2 hours, we leave those 2 hours because that's the time that the embryo actually needs to recuperate for all the stress they had from the thawing. And obviously you can actually, if the survival rate of the thawing it's not good, you will see it at the very beginning, but you will see that the embryo it's kind of dehydrated like this, and it takes time for the embryo to actually go back to the normal form and to actually be kind of a circle back again. So in those 2 hours you need to start see that the embryo is getting back to that form and getting back and not being collapsed anymore. So we wait 2 hours normally, but there's not in some places they wait more. In Repro Clinic, that's what we do, 2 hours. It's based on quite studies, and that's more or less what we do. And then in those 2 hours we will check the embryo back again just before the transfer to see how it has been doing, and if the embryo is not collapsed anymore, then you go and you transfer that embryo. If the embryo is collapsed and you can see that the embryo has not improved or the embryo has not done any change in those 2 hours, you will need to check and see actually if the survival rate it's good enough or not for the embryo to be transferred. But actually survival rates are really, really, really good, and I would say 99.9% of the embryos survive the thawing. So the vitrification and thawing, it's quite a secure procedure, and we do it almost every day for more than one patient every day for sure. So it's normally it would not be any problem. It's just more about letting the embryo go back to the natural stage and to not be that stressed just before the transfer, that it will be another stressful moment for the embryo. All right. Then another question here that actually it's quite related with what I've just said. It's which are the signs of embryo survival and embryo not survival lysis. And you can see the cells of the embryo if they are survived. If if they are alive or not, you will see like the proper cell. Just the color of the cell will give you an information about if it's alive or not. When cells are not alive, normally they get darker, and apart from darker, you will see that all the like the membranas, I don't know that word in English, like all the cells are quite round, right? At the blastocyst stage, they will create what's the trophectoderm and the inner cell mass. You will see that all the borders there are not that clear, and they start to get not consistent. So that also will give you an information, but you will see it more clear for the color of the cells. Cells get quite dark and kind of not black, but really darker than the other ones when they are not alive. Okay. And then we have here one last question. That's how many times can an embryo can be freeze and thaw? And if there's like an embryo can just be thaw once or something like that. And there's no time. Like you can actually freeze and thaw an embryo as many times as you want. There's some cases when you need to thaw embryos that you have froze, and then you biopsy them maybe, and then you freeze them again, and then until you don't have the results of that biopsy, you won't thaw them again. Obviously, thawing and vitrifying, it's something that it's an add-on procedure. So the embryos in general, or eggs or sperm, the less that you thaw, the better. Okay, but there's it's a really secure procedure, and there's if there's more that you win thawing those embryos and biopsying them and then vitrifying them because you have realized that PGT needs to be done, or because you are this now it's not that common, but before it was quite common to do like embryo batching for PGT. So it was quite common to actually freeze embryos and then just thaw them all together to do a biopsy at once for a batch of embryos, and then just freeze them again, and then just thaw the ones that you want for transfer. That was quite often done, and there's no problem with that. Is something that we do. Obviously, it's if you can just freeze them once and thaw them once, that's less stress for the embryos. But at the end, if an embryo survives the thawing, that's it. There's no like quality of the embryo won't get worse if you freeze them and thaw them like twice. So if there's a PGT that needs to be done, that's completely fine, and there's no problem with that. All right, that's all the questions that I have. I'm not sure if I have been spoken really fast about it. The summary would be that when we thaw, what we do is we just remove all the cryoprotector from the embryo. That removing with osmolarity means that the embryo will collapse and will get a bit like dehydrated, and then you need to change the media for the embryo to get back to the normal form and get all the new media in once the cryoprotector is out. That's normal, and that's what we expect embryos do. So we expect embryos to collapse just after thawing, and that's normal. That's part of it. That's part of the process. And what we do is we wait 2 hours until from the thawing to the transfer. Here in Repro Clinic, that's for us, it's quite important to get that time and just to see how the embryo proceed the 2 hours after the thawing, and see how it's going, if it's actually starting not like to get back to the normal form or not, and then to give that time to the embryo to be less stressed for the transfer. And I would say, as a summary, obviously the most problematic part or tricky part would be the part, the first step, that it's when you actually remove the cryotop from the liquid nitrogen to the TS. That's going from minus 194 degrees to 37 degrees in the less time that you can do it. So it takes actually just seconds. That needs to be done in a heated stage, and then all the other thawing procedure, it's not in a heated stage. But summarizing, thawing and vitrification, it's a technique that works really good, and that actually allow us, Repro Clinic and lots of clinics, to actually do cryotransfers that will help with egg donation, and obviously with patients with own eggs too, to actually have the opportunity to have an egg collection maybe, and then wait 1 month to actually have maybe a better prepared endometrium to actually do the transfer at that moment, and not to do everything fresh if that's a reason why. And that's it pretty much. What else? As I've said, it's a really fast process. It takes around 10 minutes, and it can be done as many times as we need. All right, embryos can be thawed and freeze again, just for do a PGT in between, and then just thaw the ones that are euploid for a cryotransfer. Okay, that's all. That's all the questions that I have. I've answered also some questions from here that you guys have answered, asked here. Aina again from Repro Clinic, and if you have any questions, you can just leave it on a message and we'll answer and reply. If you rather send us an email, that's completely fine too. We will be very happy to answer to your questions. Our email is labreproclinic@reproclinic.com. And that's it. It's been a pleasure to be here talking to you guys. All right. Bye. Finalizar, ¿no?